Underfloor heating is one of the most comfortable ways you can heat a house, or underfloor, radiant floor, staple up many different terms for the same kind of technology there. But the idea is that if you warm the floor level, the perfect scenario is warm feet, cool head. I mean, what a better way to do it. Now, I've been doing radiant floors since the 80s, and it's refreshing to find out when a coworker is building a house and he's doing radiant floor heating as well. So his name is Joe Mattiello, and he's one of our tech service guys over here at Taco, Joe Matt for short as we refer to him here. But he's in building a new project, and he's decided to go with radiant floor throughout. And I think it'd be great to go over and visit his job site, and we'll go see what products he's picked and meet the installation contractor and some other technical resources he's used along the way for his design. So let's go see his project and see what it's all about. Hey Joe, how you doing? Wow, nice place here.
Nice to see
place.
You. Thanks for coming. Yeah.
Wow, look at the space you have with this. This is awesome.
Beautiful, isn't it? I love the nice high ceilings, and I think the radiant heat is really going to help in heating this big area.
Yeah, well, you know, that's kind of why I'm here to talk about that segue of radiant floor heating. But this is like a perfect candidate for that, with the high ceilings and glass and, you know, warm feet, cool head. You know, that perfect scenario. So I'm glad you decided to do with radiant.
Me too. I'm so excited. I can't wait to operate the system.
Yeah. So the whole idea that, you know, I wanted to get together with you was talk about, you know, what made you decide on radiant, and then who did you use to install it, and, you know, ideas and where they came from, you know. So that was kind of the envisionment. Why did you think of radiant for here?
Well, being an application engineer over at Taco, I have some great resources there, like yourself and John Perry and Dave Holdorf, the trainer there at Taco, and they really helped me design the system. So,
okay.
I'm really excited about it.
You know, I was kind of thinking maybe we could bring in those two experts and let them have a little conversation and kind of walk through the house, and they can show us. You know, John put it in, Dave with his background, their radiant stuff, and let those two go at it. How's that sound?
That sounds awesome. I'd love that.
All right, let's grab them and see how that goes. Hey Dave, how you doing?
David, good to see you again.
Alrighty. Yeah, I'm glad you came. It's great, you know, have some industry experts here. Who do you have to your side over here? Who's this?
Oh, we got John Perry from Advanced Comfort.
Hey John, how you doing?
How you doing?
Alrighty.
He's the installer of the system here.
Okay.
Also helped design the layout, the control platform, the piping scenario, the boiler selection, and did all the install too, I'm assuming, right? Yeah. So,
wow, we got two experts here.
Yeah.
You know, maybe the two of you could kind of go through a dialogue and show us what we have and why you picked the system. You know, John designing it and doing all that, and let you two kind of go at it, you know, and stand back and learn from some experts.
All right, sounds good.
Thanks. Dave.
So, you know, we're a little bit different than Dave's house, and the biggest difference is really how we installed the radiant. And the radiant was installed from below the floor with the joist tracks, and here everything is the lightweight concrete upstairs.
Correct. Yeah.
And what I'm noticing, obviously, one of the biggest advantages by doing it this way was that you were able to get a very consistent water temperature.
Yeah, that's why a lot of times when I design the systems, I like the concrete method best because it gives me the flexibility to design it where I can use one water temperature. I can space my tubes so I can get everything down to one water temperature, one mixing valve, try to keep it simple.
Right, I noticed, and one of the great things, and I try to promote it as much as I can, is using a modulating valve. You know, with that modulating valve, getting the modulation of the water temperature going out to the floors, getting that warm floor all the time. Because a lot of people forget that when it comes to radiant. They just, I got radiant heat in the house. Well, when the thermostat gets satisfied because the water's too warm, because of design temps, now all of a sudden the floor's cooled down, but the air's satisfied. Getting that modulation is awesome. And then I see we got tons of zones set up throughout the house. And that's a fan of mine too, at the same time. Make every room as comfortable as you can. And by breaking it apart, and these pipes are heading out to different manifolds, different locations throughout the house, but all the mechanicals are down here, which is good.
Correct, everything from a servicing standpoint. What I try to do is I try to explain to my customers with the modulating valve is, okay, what we want to do is put your heating system on cruise control. You get out on the highway in your car, you get up 55, you press the button. You go up a hill, gives it more gas. You get it levels off. When you go down a hill, it brings it back. Well, we're doing the same thing using outdoor reset with the radiant heat system. So the way we try to explain it is I tell them turn your thermostats to 75 degrees and then set the boiler up on cruise control. That does your modulating valve for your outdoor reset. So you stay at one steady temperature, keep that water flowing all the time. Then the zone valves act as heating, to stop the heating. If the room gets overheated, it shuts it off.
Well, more or less like a high limit at that point.
Exactly.
Yeah.
All your thermostats now become a high limit control.
Right. You want to get every room, and you could change the temperature in every room and how it feels, but the one thing you're going to get is that warm floor.
Exactly.
And then zoning everything out this way here, making it easily accessible. You got the zone controllers. From a quick glance, we can see which zones are calling for heat. Joe, the homeowner, I know he's a techie, so he's going to be down here looking at this stuff all the time in the beginning. He wants to check it out and see which rooms are calling and what's on and what's off. And, you got that visual indication right here. You've also got the visual indication on the zone valves. Temperature gauges. I mean, we always see supply. Dude,
Never return.
Never return.
I like
Nice.
the return from a servicing standpoint. I want to see, okay, what's going on with this room? Why isn't it? We can get our delta T. We can see it.
Yes.
Let's troubleshoot the system.
Definitely. And then obviously with the variable speed pump, as these zones are opening and closing, that pump's going to speed up and down. Try to keep that delta T. Try to keep those comfort going on.
Now we know we can change this thing to get it to the right delta T.
Right. So sweet setup. John, looks great. Looks like you've been doing these things in the shop, right? Because this was a neat setup to do here in a basement space. And when you're that close to the ceiling and this high off the ground, and hey, probably when it was built, you didn't have that much electricity and lighting. So I've been seeing this trend a lot more lately as contractors across the country are starting to build their mechanical room, the most of it, in their shop, and then coming to the home, mounted to the wall.
We've been doing it for probably 18 years now. Building the boards in the shop. Me and my father would be in my garage. We'd build the boards in the garage, in the shop. You got much more quality. You got much more light. You can do a better job. So we mount them on the board in the shop. We bring the board to the job site. Boom. All we do is tie our supply and our return on, and all the wiring is done on the back side of the board. So
cleans it up.
It cleans it up a lot.
Yeah.
In this job here, we used a flat plate heat exchanger because he's got an air handler up in the attic. So instead of having glycol go through the whole system, I got it just in that one air handler for insurance purposes. If something, it gets cold up there or something, we don't have to worry about it bursting. But I don't have to worry about the maintenance issues with all the glycol through the whole system.
Let's go take a look at the rest of the stuff upstairs. I mean, this is all great down here. I could spend all day here, but I want to see what
we
you did.
could talk for hours about this.
I want to see what you did upstairs and how you made it accessible for the homeowner and some of the extras that you can throw in too. So let's take a look upstairs.
We'll see how the methods we use up here and show you a couple special features in the bathroom.
Okay. So I'm looking around and I see gypcrete.
No, it's just regular concrete. It's just not structural or anything like that. It's just used as the radiator. That's what's absorbing the heat. We're heating the concrete up, and that's your radiator now.
Now, I'm looking at it, and right away I can assume that we're doing hardwood floors down here.
Yes. Yep.
All right, so that's why the sleepers
That's
were
why
put
the
in there,
sleepers.
and these are the nailing surfaces.
Correct.
Right.
Yep.
And I love doing this because one of the things about the hardwood guys when they come in, they have a target. Okay, so rather than hitting one of our pipes in the floor, they know what they got to nail into, so they can see the wood very easily.
With the concrete, I think we've maybe had to fix maybe 2 tubes over the years. Other than that, quick track, you got to fix a few tubes here and there, but when you're in the concrete, it's almost bulletproof.
And I like the sleeper function here too, because now when you transition from one room to the next, from hardwood to a tile, that you don't have that big saddle. Correct. Right, well, you don't have to step up or into one room or the other. It's like a lot of times with the hardwood, we'll have another layer of ply on top, and then trying to match everything up.
We're matching. We're bringing it up just 1.5 inches. This matches what the subfloor is. That's how they think about it. But in the bathroom here now, you don't have the wood structures, so you don't have 2 different materials. The concrete shrinks, the wood shrinks. So you want to have it all concrete, so now when they do the tile, you don't have to worry about it cracking.
Right. And then obviously the other function that you can do here too is really change the spacing of the tubes. Right,
exactly.
Pack them in a little bit closer in the bathroom.
Again, that's on the design. That's like we were explaining downstairs. Is my hands aren't tied with under the floor or quick track panels. I can use one water temperature now. And in here, here's the shower area. It's a little feature that we do is we go up 4 feet into the wall, the outside wall. So now, when you go into that shower is warm before you even turn the water on.
Sure, yeah, with all that tile that's in there.
Exactly.
And definitely, I see it. And also when I'm looking at this bathroom being stuck in the corner of the house, like most of them are, You know, and you got 2 outside walls and a window in here, and now you put fixtures and vanities, and now we start running out of space where we can put heat.
Exactly.
Now you really pack it in with the tighter spacing in here and just make it that one environment. Because the bathroom is that one room of the house where you like it just a few degrees warmer than the rest of the house. You know, what I really want to take a look at is also what you did upstairs.
Okay.
So, because, you know, one of the really neat things that we can do with hydronic is obviously mix and match. So, you know, we do have some radiant heat upstairs, I believe, right?
Yep, correct.
Okay, and also have an air handler, some fan coils going in there too. Excellent. So also you did some radiant in the balcony level?
Yep, radiant all on the second floor here too, so that we didn't have to worry about the 2 systems fighting with each other if they just did just hydro air up here or
Right.
baseboard.
Right, of course, because when you do have a radiant system, the further you get away from that heat source, the air is actually going to be cooler. So we could see easily 55, 60 degrees up here. It would be cool on this balcony level.
Yep.
So I see we got some more radiant set up over here. Now, here's also what I really like about it, and having a separate AC system, right? We run into this so much across the country where I want air conditioning in the house, and then we just simply put hot air through the ductwork. Well, there's a lot of compromises that need to be made. So therefore, hey, we've got an AC system properly sized, properly designed to give the most efficiency and comfort in the house, as well as the heating system separately. It's all about the comfort all year round, not winter. All right, so one of the things that you did differently here compared to what we did over at Dave Sweet's house is that at Dave's house, we did all the manifolds down in the basement. And also because his radiant in his house was just the first floor. That was going to be the most commonly lived areas. Upstairs was more guest areas, and we didn't do any radiant up there. He's exploring some heat pump operations, a very efficient air handler system that he's got going on. So, but I see what was different is that for the second floor, you threw a couple of manifolds up here on the second floor. So what do we got going on?
Well, I do the same thing. You try to keep your manifolds close to where you're trying to heat. And the reason is for that is because you have less leader length coming off the manifold. So as soon as you come out, you're going right into put the heat right into the floor where you want it.
Okay, okay.
I've troubleshooted a lot of systems like that where a lot of the manifolds for the second floor or anything were in the basement, but then they didn't have enough flow because now you have all those lines running up. You got a lot more leader length. Sometimes you got more leader length going up to there than you do in the floor.
Right.
You know?
And therefore that goes and changes pump sizes,
Exactly.
starts the
Head
efficiency
pressure.
levels,
Exactly.
and now the comfort level starts getting destroyed. So you supplied each manifold with a larger pipe and then branched off to 2 smallers that are feeding the spaces. And each manifold's representing a zone, it looks like.
Correct, yes.
So you've got one for bedroom 2, and then the other manifold for the bath and the hallway, that balcony level.
Correct.
So this
Yep.
way, you know, again, we want that bath to be a little bit warmer. The hallway doesn't really need its own zone. We'll share it with a bath.
Correct.
The bedroom we can turn down when nobody's here.
Well, when
and
they're
the guest
sleeping,
space.
they like it a little lower temperature.
Right. So, yeah, nice, neat space. And access panels?
Access panels, some builders will put them in. A lot of times we'll go right over. Like I said, I mean, I have some out there that have been there for 15, 16 years now. We haven't had any leaks.
Yeah, sure, because there's no moving parts.
Yep.
You know, so
Because-
you could embed it if you needed to, yes.
Because we troubleshoot a lot of radiant systems, I have a thermal image camera, so we can come and we can find it, we can see exactly where they are, cut into the sheetrock if we need to, and then we can just patch it up like it wasn't even there.
Right.
People don't want the access zones. But a lot of the manifolds, like you see in this one, we put in the closets.
Yeah, okay.
You know.
Hey, John, I see you took Dave all the way around. How'd that go, Dave? Did you get some good indication of how the system is working here, or what?
Oh, yeah. I mean, you know, again, a little bit different from your home. Same goal, comfort in mind. But that's the beauty of hydronics, that we can do a lot of different things with it.
Right.
So Joe's home here, you know, he wanted a certain way. John looks at a certain install
Right.
that he is comfortable with and knows works well over
Right.
the last 18 years with his
Right.
company. So by doing the concrete system, adds a lot of mass, adds a lot of comfort,
Right.
but a lot of flexibility too.
Yeah, and like I say, you know, you've done plenty of jobs. You know exactly what works and what the homeowners are asking for. I think that's the big thing. You emphasize listening to the homeowner, creating an action plan based on what their needs.
That's the big thing. I mean, you got to realize we're still with the customer, even when the house is all done and the builders are gone. We're still with them.
Yeah.
We still have to.
Yeah,
you
see, a
know.
lot of people forget that. So anyhow, but that was awesome. Well, I really appreciate you two getting together. You know, Dave coming up and John showing us the install here and kind of walking us all through so we can see how it is, remote manifolds and the boiler set up, and that pre-made panel looked awesome, you know, and wired up and plumbed, and that was all great stuff. So thanks, guys. Really appreciate you coming.
Good to see you,
man.
Dave.
All
Thank
right,
you, Dave.
take care, John.
So Dave, what'd you think?
Oh, it's awesome, awesome. You know, every job you go on to, you know, I really like to look around and see what, you know, homeowners or engineers or, you know, contractors are thinking when they design a system, you know, especially when it comes to heating like this. You know, with my background and radiant heat and all that, it's great to see other minds are thinking the same way, you know, and it's you know, I think it's great how you met with John and talked about your installation and kind of got that feel for the vibe for each one and what would the system be best.
A lot of thought went into it, and I'm so excited about it. I can't wait to start using it.
Yeah. You know, and you know, between the comfort level you're going to have with the project, you know, that's going to be awesome. And you know, the simple maintenance and all the way that you've got the system planned and put there that nobody has to go out throughout the building, everything in the mechanical room. Very wise decision on your behalf to do this.
Thank you. Thank you. Yeah, everything's going to be low water temperature, so I expect to have low bills over here too. So I'm excited about that.
Right. Well, that's awesome. Best of luck with your project.
Thank you so
really
much for
is
coming.
great to hear about that. That was awesome. You know, we had two industry experts there, really super to kind of walk us through the system, point out the components, different way of doing things. Like I said before, slightly different than my project. You know, where they did both jobs, we have it in a slab, but it's that overpour method they did here for mass, where I did more of a dry method. But, you know, it's great education. Everybody out there, hopefully you learned a lot from this episode. It really talks a lot about different ways of doing it. But the main thing is indoor comfort, getting all these systems to work together, and you really need a professional contractor to make it happen. So thanks for listening.